Welcome to solverfy.
So monochromatic light is incident upon a pair of slits. The distance between the slits is 2.4 times 10 to the negative 4 meters. And we have an interference pattern on the screen. The screen is 1.80 meters away, so we call that L. The first order, so M is equal to 1, bright fringe is at a position of 4.52 millimeters. So from this information, we want to predict where the fringe for the 50th bright line would be. So first they ask us to just take our answer for the first one, which is y1, and multiply it by 50. So y of 50 would be 50 times 4.52. Whoops, is that millimeters? Yes. So 4.52 millimeters, and that's going to be equal to 226 millimeters. Okay, and then in part B, that's the answer to part A, find the tangent of the angle of the first order bright fringe. So we can do that by basically looking at our trig here. If this is our angle here, and this is what we call y, and this is what we call L, the tangent of theta is just y over L. So in this case, the tangent of our angle is 4.52 millimeters over 1.8, but 1.8 is in meters, so I need to have the units be consistent, so it doesn't matter which one you change. I'm just going to choose to change the denominator to 1800. So the tangent of my angle, which is what they're looking for, is 0.00251, or 2.51 times 10 to the negative 3. So then the next part, we're asked to find the result of part B and equation 37.2. We need to find the wavelength of the light. So equation 37.2 is just the d sine theta is equal to m lambda for a bright spot. So we need to find what the angle is. Well, this is the tangent of the angle. So if we just do inverse tan on our calculators, the angle itself is 0.144 degrees using 3 sig figs. So now we want to find the wavelength of this light using this equation. So we can plug in our d. Our d is 2.4 times 10 to the negative 4 meters times the sine of the angle, and that's equal to 1 times the wavelength, because this is for the first bright spot. So plugging that into your calculator, just 2.4 times 10 to the negative 4 times the sine of 0.144, we have a wavelength of 6.03 times 10 to the negative 7 meters, which in nanometers is 603. So that is the answer for number C, for part C. Then we want to find the angle for the 50th order bright fringe using 37.2. So 37.2 again is d sine theta is equal to m lambda. So we're looking for the angle for the 50th. So I plug in my d. I don't know the angle, so this is sine of theta, but this is equal to 50 times the wavelength. So 6.03 times 10 to the negative 7 meters. So we are looking for the angle. So we have the sine of the angle is going to be 50 times 6.03 times 10 to the negative 7 divided by 2.40. So I can write that out. Sine of the angle is 50 times 6.03 times 10 to the negative 7 over 2.40 times 10 to the negative 4. So when you enter that all into your calculator and do the inverse of the sine, you get 7.22 degrees. So that's the answer for part D, which they're asking us to do multiple steps. So then for part E, they say find the position of the 50th order bright fringe using this equation. So using equation 37.5, which is just that the bright spot is equal to L times the tangent of the angle. So since I know the angle, pardon me, my thing is messing up here. Tangent of the angle. So since I know my L is 1.8 meters and the tangent of 7.22, I plug that into my calculator and I get 0.228 meters. I don't really need that parentheses here. So 0.228 meters. Now, if you recall in the beginning, we predicted that the 50th bright spot would be at 0.226 meters. So why is it different? They ask us in the last step to compare the answer or comment on the agreement between the first answer and the last answer, the 0.228 versus the 0.226. And it's because we made the approximation in our argument here that the sine of the angle is about equal to the tangent of the angle, which is true for small angles. Okay, this here, y, and this is L. Sine of the angle, these are about the same, right? The hypotenuse is about the same as the distance away. But as that angle gets larger, which happens when the order increases, we're going from m is equal to 1, which is real close to the center, to m is equal to 50, which is way farther away. That L and the distance directly to the screen is not exactly the same. So the higher order you get, the less agreement you'll have between the two methods of calculating. So that's it.